Well, good morning, everybody. This is Max Rockefeller with ShopWare. I am the sales engineer for Markforged. I support customers with their interest in additive manufacturing and how it might benefit them in a future state, rather than just using subtractive manufacturing or CNCs or other technologies. This morning we have an hour budgeted of time, and FYI, I don't think we'll need the entire hour, but essentially what we're going to do this morning is go over who Markforged is and what they do. The purpose of today is to get familiar with how to 3D print with composites and the continuous carbon fiber or the continuous reinforcement that Markforged offers. Excuse me. The third part of today is we'll take a brief run through the Eiger software. The Eiger software for Markforged is their slicing software. That will be the environment that if you are working with somebody that owns a Markforged printer, or if you had one in your shop, that would be how you'd be interacting with the hardware, STL files and things like that. Again, an overview of Markforged. I convey to people that they're analogous to Apple in the sense that it's their software, their hardware, their materials. Same thing in the Apple environment. If you don't like Apple, that's fine. But the point is that you'll have a certain level of quality that is only achieved by having all three of these facets integrated together. One of the concepts or points that the guys at Markforged, who are out of Boston, that they talk about is that the fourth industrial revolution, or Industry 4.0, about digital manufacturing and how 3D printing is a part of that. So we had the steam engine, we had the assembly line, we had robotics. Industry 4.0, as much as it sounds like a marketing tagline, it is being dubbed the fourth industrial revolution. Digital manufacturing, 3D printing is one of those pillars. You can see here we can look back to the early 20th century, and now we're looking at the 21st century digital manufacturing automotive assembly line. A lot has changed. Today, again, we're talking about composite printers, and so I've highlighted the Mark II and the X7 from Markforged. The third printer you see on your screen is the Metal X. We won't be getting into that today, but the Markforged Metal X prints with 17-4 stainless steel, A2, D2, H13 tool steels. On the roadmap for later this year, titanium, Econol. Further down in 2020, at the latest, copper 6061 aluminum. And that has a wash station and a sinter oven that goes with it. We can certainly talk about that individually if there is an interest in metal 3D printing. Back to the Mark II and the X7, a very common question that we get is, what's the build volume? How big of a part can I print? And the Mark II is a desktop printer. As you can see by the graphic, it's 12.5 inches by 2.5 inches by 6. The X7, which is a freestanding printer, we're looking at 13 inches by 10.6 by roughly 8 inches. These are the two primary Markforged printers that print with continuous reinforcement, which again is what we're here today to learn a little bit more about. Markforged has this technology patented within the world of FDM printing, fused deposition modeling. So basically we're extruding this material through a heated nozzle at about 270 degrees Celsius. Both these printers, again, I'm contrasting to other 3D printers that are out there. These printers don't need heated chambers, and they can print down to 50 microns, and you can print with a continuous reinforcement. which is the ability that these printers have so that you can achieve material property strength as strong or stronger than 6061 aluminum when comparing stress strain curves, modulus elasticity, and other quantitative aspects. One other point to touch on before we carry on here, the base material, the composite, if you will, for Markforged is called onyx. Excuse me. Onyx is a nylon 6 and it has 20% chopped carbon fiber. Because of that, and thermal expansion properties of a material with 20% carbon fiber, you don't need a heated build plate. You don't need a heated chamber. You don't need to spend an hour warming up. And you can use the same fiberglass build plate for every print job. In other words, no one-time use print sheets. So just to review here, you have your step file. Maybe you've created it in SolidWorks. Step 2, you're going to slice and reinforce. That is within the Eiger software. We're going to get into that after maybe another 10 minutes here. And then you're going to print your part. CAD, step file to STL file to physical model. Thought that I would convey to you folks some of the other Markforged customers around the world. There's a lot of recognizable names on here. The U.S. Air Force is one that is interesting because they have essentially deployed Markforged printers in the field or theater of combat, in a sense that they have these large shipping containers like you might see on a semi truck being hauled around, that they'll drop in a combat zone with printers inside of them at their own power supply, and they can print repair parts right there in the field or theater of combat rather than waiting for the logistics and the supply chain to machine and ship them to wherever they need to be. The materials, we talked about the base material onyx. So to compartmentalize this, we have a base material onyx and we have a reinforcement. The reinforcement is like rebar and concrete. It strengthens what you're laying down, layer by layer. Carbon fiber, Kevlar for impact resistance, fiberglass, and then if you have maybe a welding bracket or something where the environment or ambient temperature dictates it, you can go with high strength, high temp fiberglass. Just as a side note, there are 2 other base materials. There is a flame retardant onyx, and there's also a white nylon, which is paintable, which is non-marring, and allows the customer just to print with just nylon. All of those materials are available on the Mark II and the X7. Stress strain curve. The main takeaway from this guy is if you look at the white 6061 aluminum, you have an inflection point and it's right around where the carbon fiber interacts, or intersects, I should say, 6061 aluminum. And so when we say as strong or stronger, this is the data. This is the data that we're referring to. Down in the lower right-hand corner, you're going to see ABS, nylon, and there's that onyx material from Markforged. Just the base material of onyx, because it has 20% carbon fiber, is going to be stronger than ABS and nylon. If you're out there evaluating a 3D printing solution for your shop or your garage at home or whatever the end use is, onyx is inherently stronger because of that chopped carbon fiber. And again, the main differentiator of Markforged is that you can reinforce that onyx with the carbon fiber, the fiberglass, or the Kevlar. So What you're seeing here is it's a handout that within the GoToMeeting, let's call it a dashboard, that typically guys like us have pinned to the right-hand side of the screen. It should say handout 1 of 5. This is a PDF that you all are able to download. I might have to click on it here, or Matt and I need to figure out how we can make it available to you. So let's just run through this thing. I'm going to skip pages 6, 8, 11, and 12. And I hope I realize the text is a little small, but we're gonna go through the main takeaways here, and then we're gonna get into the Eiger software. So this is a quick reference sheet, part of this designing for composite printing. On the left-hand side here, it's essentially telling us that we have these build volumes that we referred to earlier. Again, the Mark II is 13 by 5 by 6. The X7 is 13 by 10.6 by 8, roughly. And when you're printing, you have minimum sizes. And so this is important because not everybody's part is going to be at the maximum size of the build volume. And there is a minimum for which you can actually reinforce a part. So in other words, the minimum part size is 1.6 by 1.6 by 0.8. There's not enough room to lay down carbon fiber reinforcement. The next page will show us what those minimum requirements are. But in this instance, you can see there's on the left-hand side, there's a minimum 40-degree angle where you might need supports. And there are minimum sizes and size restrictions on different facets and posts and diameters. Again, we'll make this available to you, or I can email this individually to you guys. This sheet right here, so there's a lot of stuff where you can get into the weeds. But I want you all to be aware that this information is available, and this information can be disseminated and why it's important. So when you're identifying 3D printing opportunities, what the right-hand side of this, what we're viewing right now, is important when it comes to the commercial aspect of, does it make sense to own a printer? What's my payback? Is it going to take me 5 years? Is it going to take me 5 months? So when we engage with manufacturers about a 3D printer, there's the technical box to check, there's the commercial box to check. So not a new concept here, but depending on the volume and the complexity of the geometry and the forces involved, a part may or may not be a good candidate for 3D printing. The section on the right-hand side where it says calculate the ROI, that graphic above the cost per part quantity curve is essentially showing us that you might have a design for a part that is based on subtractive manufacturing, but if you take the time to redesign it a little bit, you can design it for additive. DFAM, Design for Additive Manufacturing, DFAM, is it's a new acronym in the world of Industry 4.0. Essentially, designing for 3D printing can be optimized, and it's just a slightly different mindset. And you guys, I think you guys get the idea. Going ahead here to page 5. So we'll focus on the left-hand side right here for a minute. When you might have a candidate for a benchmark part, or if you have a part you're considering to 3D print, not only is the cost justification, or does it make sense question coming to mind, but also the technical. And when you're considering the technical aspects, you also have to start thinking about how is this part going to go on the print bed. You want to lay the part down so it has a maximum amount of area in contact with the bed. If through holes are of a critical importance, if those dimensions are critical, you want those through holes in the Z rather than along the XY plane. If you have forces in tension or compression, and we'll get into that in a little bit, that will determine how you reinforce it with carbon fiber. If surface finish is of importance, maybe you're making a pattern for sand casting, you might want to print with 50 micron rather than 100 or 200 micron. That takes more time, but is probably needed by the application, right? So again, this sheet goes into the weeds here on all these different topics, and we're going to keep skimming along here at the high points. With 3D printing, you can get a little creative. Some customers say, I need reinforcement. The chips I'm making when I'm milling this part are wearing on my onyx. Well, you can design for inserts. We do have some customers that are starting to use electrolysis nickel plating. So instead of milling an insert and attaching that, it's nickel plated, a few mils or less, and that helps when you have really thin parts. You can also put heat set inserts in the parts to strengthen through holes, to add threads, and so forth. And again, this part of the spreadsheet, this part of the PDF talks about alignment, wear surfaces, backing up to the inserts. You can literally pause your print mid-print, put down an insert, and keep on printing. That's one of the cool features of the Markforged printers here. We're going to jump over page 8. And so here we are. We're finally talking about reinforcement. On the top of the left page here, we've got carbon fiber, we've got fiberglass, we have high temp, high strength fiberglass, and we have Kevlar. So we've mentioned all of those. They each have their own physical characteristics. So regardless of which reinforcement that you might be considering, you want to make sure you lay it down correctly. So this is where we get to the point where your part might fail or it might succeed. And I'm going to compartmentalize this and convey that there's concentric fill and there's isotropic fill. That's the big takeaway from this part of the presentation. Concentric fill is basically laying rings of carbon fiber around the perimeter of your part, whether it's 1 ring, 2, 3, or 4 is up to you, and I'll show you how you do that. But you want to put that over, if we're looking at the middle part of this page here on the left, you can have all the walls, the outside, the inside through holes. You can have the outside only, or you can have the inside only. All that is set up in the Eiger software. Again, concentric is just rings. Think about it again as rebar and concrete, rings around the outside perimeter of the part. What if you said, Max, I'm making a mandrel, I'm bending 18 gauge tubing? Well, gosh, you probably want isotropic fill. So isotropic fill is literally every layer from edge to edge at every, you're looking at a triangular latticework infill. If you were to chop the part in half and look at a sectional view, that means isotropic fill is having carbon fiber laid down on every side of every triangle wall throughout the whole part. It is not inexpensive, but you can do it, and some applications demand it. again, bending tubing over a mandrel, just to name one. On the right-hand side of our handout here, and again, Matt can either figure out how to make this available or I'll email it to you guys.
I think actually they should see it as their handouts section.
Okay.
I clicked on it and it just popped it up on my screen. So. Okay.
Sounds like it's available. The right-hand side of this, what we're looking at, page 10 here, is again, parts might be in tension, compression, and then in a bending application, you've got both. There's different ways to lay down fiber that maximizes the strength based on the load and the type of load that you're seeing. Page 11 in page 12 is more of a deep dive on reinforcement. Again, I want to show, based on your guys' experience level, that this information is here, it is available, it is documented, and if we were to talk about a part, a benchmark part, or if you were to ask for some support on a part, you know, this is the type of conversation we would be having. Also, when it comes to carbon fiber reinforcement, not only is there concentric versus isotropic, but you can also change the fiber angle. That's important because if your load is coming from this direction or that direction, you want to lay your fiber in a specific orientation that counters that load. So we'll show you in the Eiger software how that can be manipulated. So if I am able to do this correctly, I am going to bring up, Matt mentioned that there is a question box in our GoToMeeting here. I'll pause for a second. If anybody has any questions, or if there's something specific that I can focus on here in our last 5 or 10 minutes, now is a good time to raise your hand and let us know. Okay, so why don't we go through the Eiger software. So this is the third part on our agenda this morning. The Eiger software is a cloud-based slicing software that Markforged, through their own software development, have created for specifically their printers. The cool part about Eiger is that, and most slicing software will do this. I'm going to zoom in and hopefully it, yeah. Okay, there we go. So this part is called an ARM. It's for a gas-powered model airplane. And essentially, when you're thinking about the commercial side of, does it make sense to own a printer and print these parts, you probably want to know what your material cost is. So Eiger will tell you down to the penny what your material cost is, the mass, that's important. If you're on the end of a robot, end of arm robot tooling, or you're lightweighting a part, that's also, or a part of a larger assembly, and how much volume of the plastic, that's onyx, and how much of the fiber volume, in this case, it's carbon fiber. So assuming that you can see my little pointer here on my mouse, when you were, and by the way, if anybody wants to have their own demo Eiger software, I know one of you owns a printer, the others do not. If you ever want to play in the Eiger software, that is available, and it's available on Markforged's website. There, if you'd like me to send you a link, I can, but you can go on there, request a demo account, you can upload parts, you can play with the reinforcement, you can see the cost, you can see the time, and yeah, so in this case, well, I maximize my screen here. In this case, We have onyx, and again, I mentioned all these other materials earlier. Flame resistant onyx, nylon white. These are the 3 metals that we can print in. So we're printing with onyx because we're talking about composite printers. When we are talking about reinforcement, remember we talked about fiberglass, carbon fiber, Kevlar, and high strength, high temp fiberglass. So we'll stick with carbon fiber. I'm going to zoom out here. Part settings. So here's all the parameters. So when you upload a part, you pick onyx, you pick your reinforcement, and then Markforged has a lot of the other parameters set as standard, and you can tweak them based on what you're doing. In this case, this part doesn't need supports. You can change whether or not you want supports or not. This little mini graphic that popped up, it basically supports in the Markforged world are printed from the base material, the onyx. It's the less expensive of the two, carbon fiber versus onyx. And it's printed in a way that can be easily detached by using your fingers. If you have a through hole, maybe you need a butter knife or some needle nose pliers to get it out. Other printers out there have water soluble supports, not Markforged. These are removable supports. If the part has is curved like the example in this pop-up box, or if your angle on, say, a welding bracket is greater than 40 degrees, it's going to print supports, and you're going to need it, or else the material of your part will just fall down. In our case, we have a layer height of 125 microns. That is the minimum layer height we can print with reinforcement. I mentioned printing with 50 microns earlier. That is if you're on the X7 printer and you're not using any reinforcement, you can go down to 50 microns. So I'm going to close up part settings. We'll look at material settings. The infill, or the lattice work on the inside of the part, can be solid. It can be rectangular, hexagonal, or triangular. Markforged recommends triangular with 37%. I printed a part once with a fill density of 28 to save time and money, but it always doesn't work because the material on the top and the bottom, say you're looking at a cube, it might sag a little bit. So if aesthetics or just having a professional looking part are important, we're going to sit here at 37. And you can play with these, go through iterations, go through trial and error if you own a printer and you're using the Eiger software to what works best for you. Roof and floor layers and walls are the next two settings here. These are interesting parameters because, so roof and floors is the top, highlighted in blue, right? And then down here, the floor. So how thick is that wall before you get to that triangular infill or lattice work, right? So if you're not gonna attach an insert to prevent the excessive wear of a part, or maybe it's in a sand casting application, you can make the roof and floor layers 10. It'll be really thick. And then in the middle of the part, it'll be the triangular infill. The walls, same concept. In this case of the part, we have a lot of curved surfaces, but the wall is the side. Each layer is, whether it's a roof and floor or a wall, is about 400 microns. So, we're sitting at 1.6 millimeters with 4 as our default, and 800 or 0.8 millimeters if our walls are a thickness of 2. If you had a metal 3D printer, this would be even more important if you wanted to post-process, face, turn down a part, what have you. You can machine these guys after the fact. you might do that to open up a hole or do something for surface finish. The point is that in addition to the reinforcement topic, there's also how thick do I want my walls or my roof and my floors. So I'm going to close up material settings, go down to reinforcement settings. These are grayed out, and they're grayed out for a reason. That's because, or I have set the carbon fiber reinforcement for this part. This is grayed out. That's because I did all the work in the internal view. So if you said, Max, I got a part, in this case, it's going to be in tension because I have these bolts coming through here, and this is supporting the landing gear on a gas-powered model airplane. You know, one of those like $5,000 or $10,000 airplanes that people bring to local airports to fly for fun. Okay, so the blue perimeter around this part, that's carbon fiber. And you can see that it's on the top and it's on the bottom. By default, what Markforged will do if you turn on carbon fiber reinforcement is it will reinforce a few layers on the top. Oop, I'll click over here. A few layers on the top. I know that blue is a little faint. And a few layers on the bottom. Not as faint. So we're kind of looking at like a ghost image of the part. The blue is the carbon fiber. The gray stuff you're looking at is the onyx or the part. This part has 40 layers. If you can follow my mouse in the upper right-hand corner. If you come down here, I can say to myself, well, I happen to click on layers 1 through 8. I can drag this all the way across. Catch up. Cloud slicing. You can decide layer for layer what you want reinforced. If you want out of a 40-layer part, only layer 2 reinforced and layers 1 and 3 through 40 not, you can do that. You can have all of the layers reinforced. This is how you do it. You use the sliding bar at the bottom. So now we have a lot more blue. That's more pronounced, right? So this is customizable. Going back to concentric or isotropic fiber, you can see we're at concentric and we have just layers of fiber around the perimeter. If you want to choose isotropic, you first click on which layers you want to do that. In this case, I'm going to click on the layers 33 through 40. I'm going to change it from concentric to isotropic. If our Wi-Fi is fast enough, this will slice and save in a fair amount of time. There you go. So now I'm going to zoom in. And if you remember in the past, I said concentric is just rings around the perimeter. Isotropic is everything in the middle. And if you look right now, you can see that, I know it's a little faint, but there are all these blue lines in the middle that outline every piece of triangular infill. That's isotropic reinforcement. If we go back to the concentric reinforcement of layers 1 through 28, again, we've got both types of reinforcement in this part as a demo. How many rings do we want? Well, I want it to be pretty strong. So 2 rings is default. I'm going to go to 3. So some people ask, Max, what's physically going on when this printer is laying down carbon fiber? So there's one print head, there's 2 nozzles. One nozzle's onyx, one nozzle's carbon fiber. They're each around 270 degrees. They're pretty hot. And if you were printing this part, you're printing 125 micron layers, the first layer. Because we have layers 1 through 28 with reinforcement, this printer is laying down carbon fiber in between the layers of onyx that it's putting down for the walls, for example, for concentric fill, because again, they're rings around the perimeter. So are we laying down carbon fiber on top of the onyx? It's inside, so to speak. So the printer isn't laying them down. They're being done in series, one after the other. So put a bunch of onyx down. That's one nozzle. Go to the other nozzle, lay down carbon fiber, cut it, and then go back to onyx for the next layer, layer 2. So it's either printing either or, one right after the other. And so we're going to go back to layers 33 through 40, or again, isotropic fill. We can also affect the rotation percent and again the fiber angles. So when you're in your part for isotropic fill or fiber, the angle of the fibers relative to the load is important. For example, because this part is essentially 40 layers or 40 sandwich layers, you wouldn't want that to potentially shear. So you might want to lay your isotropic fiber perpendicular to that, for example, right? So we're 45 minutes in, and we've did an overview of Markforged. We looked at a PDF that had the essentially design parameters for 3D printing, and we just ended with a demo of the Eiger software. With that said, I'm either going to hand it back to Matt here.
So yeah, it looks like we don't have any questions coming in, so we'll wrap the webinar here. Thanks again, everybody, for attending. And again, if you want to review the material, we'll have this up on our YouTube channel later today. Thanks.